Yeah, I'm going to start now. So this talk is about an information retrieval platform, and my name is Marco Masetti. So a very short bio. Perl coder since 2000, so I mean I have gray hair, you see. And so working in an R&D department for an Italian SME, we do IT, and I carry on EU-funded projects, and since 2006 I deal with information retrieval domain, I mean, and I've trusted several topics. Since 2006 I started with sponsorship tracking, for example, which means find out the relevance of sponsors in sport events. So find out metrics to evaluate the return of investment of sponsors in sports events. Then I addressed advertisement campaigns, then I clustered news, then I have indexed millions of files in file systems, and then a lot of other stuff. So what I'm trying to do is to do research and then to bring the results commercial. Okay, and this is the list of the other conferences I've attended since now, and well, not so many. I know people that attend this conference every year, but it's better than nothing. So it's since a while that I hadn't attended our conferences, and I like to see old friends here, but I also saw a lot of new faces, so this is nice. It means that Perl language is active. So again, so let's start really now talking about information retrieval. So what is information retrieval? So basically, it's finding information, basically. So finding information, but actually that satisfy an information need. So this is really important. So at the end of the day, you have a customer, you have to satisfy. Okay, this is really important, because knowing that when the information that you release to your customer is really the right one, actually it can be really tricky. So this is a citation from a book of Manning. Who knows this guy? Okay, have you read this book? An Introduction to Information Retrieval. Okay, it's really an introduction. It's a book of 600 pages. So, so it's not funny to read. The funny thing in the book is the title, because actually it's not an introduction at all. It's really thick. It's thicker than the. Okay. So my platform is it's a platform that you can use as a core platform to build information retrieval systems on top of it. So basically it does nothing. Okay, so you have to use it to build your information system. So and it comes as a single distribution. So so first some concepts. So in Mir you can configure what I call acquisition campaigns. So a campaign is split into phases. So you have to acquire your data from the data sources you want. So you, for example, emails, file systems, websites, Twitter, social networks, and so on and so forth. Events from IoT, whatever. Then you have to store from the sources you collect metadata. You have to store this metadata somewhere. And then you index the information that you get out from metadata. So information basically can be, as most of the sources I deal with are structured. You have to extract text and you have to index text. From then on, there are several other stages. For example, you have to crunch your data more with using MapReduce or other techniques, or you have to cluster your data, and at the end of the day you present on a delivery system, which is not part of a platform. with Mir, you can configure several campaigns, as many campaigns as you want, and several campaigns can run in parallel. So basically the core platform is domain agnostic. Okay, so it doesn't know what a tweet is, doesn't know what an email is. And it's really highly configurable, and it's can easily scale. Your limit, it's only the hardware. And it's implemented in Perl 5, basically modern Perl. So everything is geared around Moose and MooseX extensions of Moose. So namespaces. If you read ICQ, it means all things acquisitions. Store means all things metadata storing. IR all things indexing and the indexing component. Mirconfig for, of course, for the configuration. Util for the utilities. And then, when you install Mir, it will copy in your executable directory, so basically where the Perl interpreter stays, some scripts. So okay, it will pollute your executable environment, but actually the coding names, it's this one, so you should not, this to avoid name clashing. Okay, so again, everything with the Mir, with the ICQ has to do with acquisition. I will show you how to use these scripts later on, and this for the information retrieval, and so on and so forth. So Mir is on GitHub. So this is my user, and on GitHub you find the Mir module, but you found also two other interesting distributions, which are basically to I/O backend for the music storage Moose role. Who has used the music storage Moose role? Who knows about it? Nobody? Okay. So basically, the music storage provides you a persistence layer for your objects. Okay, it's very cool. And it has already some I/O backends, but it didn't have the backend for Mongo and the backend for Redis. So I've implemented them. Okay. So using these backends, I will show you how to use them. You can create your objects, and you can store your objects on Mongo or on Redis. Okay, look into the Mir repository. A little bit deeper, you will find 5 modules. Can you see this slide? Can you read it? Because I can't read it from 1 meter. Okay. So here is written driver role. Okay, this package is a small package. Actually, it's again a role that implements the driver interface pattern that I use extensively in the Mir platform. And another package that could be useful is this one, Mirconfig. This actually it's a REST service, REST server built on Dancer. That allows other components built on other technologies to interact with the configuration. Okay, so because usually you're in information retrieval system, actually it doesn't work alone in the dark, but actually has to interact with other systems. Okay, more often than not. Then there is another little component which it's Mirstat, which add a little bit of statistics. So automatically it will add counters. Okay, so it will count how many documents you store, and how many documents you have indexed, and so on and so forth. Mir-util doc handler, it's a package with a lot of modules that allows you to extract text from a good range of document types. And this is not part of the Mir, because actually we use it also for other projects. So this is a self-consistent library you can use apart from Mir, and then there is Mir. Okay, deployments. So you can deploy it quite easily and have quite simple configuration. For example, you configure a stream from acquisition of a small number of fetchers. I will introduce fetchers in a couple of slides, and then fetchers store metadata in a metadata store, and this metadata get indexed, and but you can have also more complex deployments. So your system could be distributed and could leverage on top of on a cluster of on a Mongo cluster, and indexing could be again an Elasticsearch cluster. So basically, there is no limit. Only your fantasy is the limit. Okay, of course, when you deal with such complex configuration, it's an issue. So knowing what is running, where, and how many fetchers are running, and what are they acquiring, and where the metadata gets stored, it's not easy. So we'll talk about the configuration right now. So configuration. So configuration is split into sections. So there is one section for the Mir platform, and you can use other sections for other subsystems. Configuration can be centralized in one node. For example, for small systems, I like to centralize configuration. But if the system gets bigger and bigger, another way is also to distribute the configuration as well. By default, so if you don't instruct your processes in another way, all the processes will address your Mongo server, their local Mongo server, trying to find the Mir database, and will address the system collection, where they should find the configuration. Okay, all the processes, they are kind of stupid. So when they start, the first thing, they fetch their configuration from here. But you can also instruct them, for example, to fetch the configuration from a JSON file. So for test purposes, you can use JSON files. So again, Mir lets you configure acquisition campaign. Acquisition campaign is a stream of processes from acquisition up to indexing. So in the system section, we'll find one configuration item, basically one Mongo document for each acquisition campaign, and one configuration item for the Elasticsearch engine. Okay? I will show you now maybe what's in what this doesn't mean. So can you see this? This is RoboMongo. It's a client for your Mongo data store. So I've already opened the Mir database. The Mir database, there should be a system collection. In this system collection, there are two documents. One document has the Taka campaign, and there is also another. Of course, you don't see this, but maybe if I do like this, do you see this? It's maybe a little bit clearer. Do you see this? Hardly, yeah? Okay, so how a campaign is configured. It needs some parameters. One parameter attribute is the fetchers. This is an array, the list of the fetchers of your campaign. For each fetcher, there are the list of parameters for the fetcher. Okay, and you see this is the fetcher driver. I will show you later. And one key parameter is this section, the storage I/O parameters. This allows you to tell where the metadata gets stored, so where the metadata collected by that fetcher gets stored. So you decide at configuration time where all the metadata gets stored, fetcher by fetcher. Then there is another configuration section for the index server. So where the index server is and which port you should respond, and so on and so forth. And okay, I will show this later on. Instead, in the Elasticsearch section, basically you can configure you can customize the behavior of your Elastic. So for example, you can define the document mappings, different document mappings, or other customization parameters for your Elasticsearch. Okay, back to the presentation. So we talked about configuration. Now we talk about metadata, which is the first step. So first you define your metadata, and then you go on. So what's a metadata? Metadata, it's basically a Moose class. Basically a Moose class that should extend the base Mir doc class, or should at least consume the Mir doc role. Okay, so everything that starts with Mir R, it's a role. And the Mir doc role defines the behavior that should be the base for each document. I will explain you later why you should do this. Okay, the Mir doc class in turns consumes the driver role and the Mir doc role. So the Mir doc role, you get it either in one way or the other. The driver role is very simple and lets you create any object starting from the base class with the create method that comes automatically by magic, consuming the driver role, and you can pass the driver. Okay, so here it's hard-coded, but usually this one comes from the configuration. So you can also decide at configuration time which kind of metadata a fetcher should create. The Mir doc role in turns consume the music storage role. The music storage role, it's really cool because it allows you automatically to call this. So to create an object, you fill up the object, and when you want, you call the store method, and the object gets persistent. Okay, it's very cool. So a metadata object is usually created by the acquisition fetcher and passed through along the chain, usually being enriched each step by step. Okay. So fetcher design. So if you follow the practice, so fetcher design is quite simple. So what is a fetcher? Fetcher, it's a bit of logic. I mean, it's domain-dependent logic that gathers data from a given data source, okay, and creates metadata. Fetcher comes as Perl distributions, so are plugins, so they are not released with the core, okay. And each fetcher should consume the Mir ICQ fetch role and belong to that namespace. So basically, very basically, so to build a fetcher, first you design your metadata first. So for example, let's deal with Twitter. All boils down in fetching tweets. So you first define what a tweet is, and so you create your package, use Moose, and you consume the Mir doc role. You define the attributes of your tweets. For example, a tweet has, of course, a language and is written from a place, and of course it's text, a bunch of characters, and that's it. Of course, the attributes are many more. Then you implement your fetcher. If you respect the rules, so if you consume the Mir ICQ fetch role, all you have to do is to implement a method which is the getDocs. in the get docs, you assess your source, you get your data, whatever they are. Eventually, you create one object, one metadata, and what you have to do is to call the store. And that's it. So this is kind of magic, because if you read only this, it's really hard to understand where this object stores itself. Actually, this is, this magic, actually it's not a magic, but it's the consumption of this role that makes this happening, okay? And what actually this one does, it's storing this object in the store that you have defined it at the configuration time for this fetcher, okay? And if you want to dig more a little bit, first maybe read the music storage man page, and you will understand how it works. So using role, it's really nice. So you can really improve your software. Okay, you should really do this if you still don't. Okay, questions so far? Okay, right. So you build this little piece of logic for each data source you want to address. And this is the list of fetchers we have currently implemented. Actually, they are not free. I'm sorry, but these are implemented by my company, which has the wrong attitude toward open source. So I'm not allowed to open them to the public. So what we have built till now. So we've built a fetcher that traverses in many ways a local or a remote file system. So it traverses the file system and get metadata from each new file it bumps into. Okay. Then we have dealt with, for example, weather data. We have dealt with social networks, Twitter, Instagram, and feeds, and so on and so forth. Okay. So how fetchers are organized? Okay, basically, you can run a single fetcher from your prompt using the Mir Repository fetcher script. Okay, this is one shot. Or you can schedule the run of fetchers in background. So the scheduling, it's a little bit complex. So basically you can use a scheduler like the Chrome daemon. In your Chrome daemon, you set up the scheduling activity, okay? There is a scheduler for each acquisition campaign. When the scheduler starts, it will look in the configuration for the campaign, it will grab all the fetchers for that campaign, and it will in-queue an item for each fetcher in a campaign queue. There is a consumer for campaign queue, which is the processor, which allows you to spawn a given number of fetchers per time. Okay, so this means this is, and the queue is a network queue. So basically you can have the cron daemon and the scheduler in one node, all the queues in another node, and all the processor in several other nodes. So it seems a little bit complex, but this allows you to really fine-tune the resources occupied by your fetchers. So it happens that, for example, 1,000 fetchers are scheduled, and I don't want that 1,000 fetchers are started immediately. because they will blow up all my resources. So I can tell the processor, please start up to 10 fetchers per time, then wait for these 10 fetchers to do their job and load the new 10 fetchers. Okay, is it clear? And just to show, if you do processor, so of course, okay, processor, and you pass any parameter, even a wrong one, it should display an help message. And for example, you can pass the minus chunk to decide the number of items, so the number of fetchers to run, okay? And defaults to 3. So it will start 3 fetchers, maximum 3 fetchers at a time. But you can easily change it. So to give you a real example, you cannot see it at all. Okay, this is a cron tab from one server of we have in the company. We have many servers with these cron tabs in which I configure all the scheduling activities for the whole campaigns we have. Actually, this is a setup, a subset of campaigns we are running. Actually, this and these are the processors. These are the processors. There are so the consumer or the queue of the queue, and actually this server only deals with the indexing of the documentation we have in our company, divided by the different departments of the company. So the administrative department documentation gets indexed in one way, the CVs gets indexed in another way, and so on and so forth. Okay, text extraction. Is there somebody that takes the time? Okay, so kill me in 3 hours time. Okay, so text, pardon? 5 minutes, okay. So metadata usually refers to file of some format. You can use the tilde handler, okay, to extract text from a good range of file types. And drivers are implemented for the supported file suffix, so docx, and there are also drivers, generic drivers like Office or image that deals with all the images. So can get text out of images using an OCR component, which is Tesseract basically. And for example, we have several drivers for PDF. They have several features. So this is a simple text extraction. This one, PDF3, does a lot of stuff. For example, it tries to fetch text out of images, but it also rotates images. So if it first starts with the image as it is, if the confidence is not enough, it tries to rotate the image, tries to get the best confidence out. So because this happens, for example, some scanning machines scan your paper and provides PDF with images inside, and maybe the secretaries are very busy and just scan the document upside down. So you realize it when you see managers around the company that tries to look laptop like this, and okay. So of course the OCR system won't fetch anything, and I will rotate the image for it. So all drivers works the same. So you get the driver creating the proper driver, and all the drivers implement the same interface. So you open the document, you get a number of pages. Eventually it's one for some formats, for example images. and you get the text alongside with the confidence of the extraction from each page. Okay, so very simple. Lookup tables can be configured to use drivers for our suffix. For example, HTML file are obviously HTML files, so you can configure a look. If you find an HTML file, please use the HTML driver for it. And your executable file gets polluted with also with script. It can be used for test purposes, just to test the extraction of text from one file. Okay, you just give it the driver and the file path, and it will dump the text. So indexing, it's all based down in going to the data store, fetching the metadata, and extracting the text from the metadata. Actually, there are two modalities. He can work event-based or via polling. Okay, event-based can be used for streamlined sources like Twitter Stream. Twitter Stream are API from Twitter and allows you to connect to a channel and get connected and be fed by all the tweets that are pushed to the channel, or MPEG 7. Somebody know about MPEG 7? What is MPEG 7? It's a metadata language that can be streamed. It's used to tag video and can be used to usually stream it along with MPEG 4. Okay, and the other way is instead is polling the data store for new metadata to process. Okay, there are again two scripts, Mir and Mir polling does this stuff. And again, you can't see this one because this is another node with all the processes in indexing processing. Success stories. So okay, 3 minutes. I will end. This is basically it's the last slide. So as already said, we index all the documents in my company, and one document type are CVs. And I did this because, and I mean, it's really a funny story. So at the beginning, I went to the HR manager, and apparently she didn't know how many CVs there were in our company. Eventually, I found out that we had more than 12,000 CVs. And actually, the way they selected candidates for a job role actually involved a lot of manual operation and so on and so forth. And actually, investigating a little bit, I found out that actually the set of candidates they selected actually was wrong at the beginning. So instead, I indexed all the CVs. I had to little bit tweak with Elasticsearch because provided the good rank for a CV is not so easy. But eventually, in the end, now this is the tool the HR manager looks for when looking for candidates for a job position. And if you do the search per Elastic, actually I'm not in the fourth position because actually this is the second page. So I'm in 14th position, but it's not that bad, being 12,000 CVs. And actually I'm the first, I rank first on my colleague, because this is internal and all the one are external CVs. Okay, basically that's it. So next steps, code fixing. The code is not fixed yet. So we'll find some bugs here and there. Test coverage again. I mean, it's awful now. And improve documentation, tutorials. Then we will definitely need also a monitoring system to monitor what is running where. And I would like to ship appliances instead of distributions. So to ship virtual machines, one dedicated for the acquisition, another for storing and indexing, and so on and so forth. So please come to me maybe later if you want other information regarding this. And okay, basically that's it. Thank you very much for. Thank you. And so drop me an email if you want other information. And this is my GitHub page. Okay, thank you.